Well, hello and welcome. So, as we've been looking at these geometric sequences where you multiply by a number each time, very often we've been using big numbers, like whole numbers like 2 or -3, something like that. In reality, especially when you're basing things on percentages, you often end up with decimal numbers that aren't super big. They're usually just like a little bit above 1 or a little bit below 1. And I do want us to see how all of that works. So let's just do a little bit of practice here with our percentages to start with. So for each one of these, I want you to do a quick pause, try yourself, and then unpause when you're ready to check. We'll see how we did. Okay, so here we go. We got 50 pounds increased by 10%. So you try yours, and then unpause when you're ready to compare with me. So we've got our original 50 pounds, and then we're going to add on 10% of that 50 pounds. So let's think over here for a little bit. 10% of 50 pounds. Well, a couple of things that I want you to remember. You've seen this. It may have been a little while. When you see the word of, that means to multiply. So of means multiply. And when you have a percentage, you're going to want to turn that into a decimal. The way you do that is you move the decimal backward 2 spots. So 10% is equivalent to the decimal 0.10. Now you don't need to write that second 0, which is why I did. So 0.1 times 50, multiplying by 0.1 is actually just going to move that decimal over 1 spot. So it comes out to an additional 5 pounds. So how much is 50 pounds increased by 10%? 10% of 50 is another 5 pounds. So the total is 55 pounds. Hey, next up, $90 decreased by 25%. Once again, I would like you to give this a shot and then unpause when you're ready to check things. So this time, since it's a decrease, let's do a subtraction. Let's think about what 25% of 90 would be. Again, we'll come off to the side here. So 25% of $90, turn that into a decimal. So move the decimal 2 spots, 0.25. Of means multiply, and then 90. This one's a little harder to figure out, so I'm going to use my calculator. Times 90 comes out to 22.5. So in terms of dollars, it's $22.50. So take minus $22.50, and then let's see what we have. So $90. Whoops, I want my calculator. So $90 minus $22.50 is $67.50. Okay. Nice, nice. Next up. How much is X increased by 7.5%? So I didn't give you an actual number to start with this time. So we're going to have to think a little bit more theoretically. So here we go. We've got our original X. We're going to increase by 7.5% of this X. So again, let's think off to the side. Now to turn this into a decimal, move the decimal back 2 spots. So 1, 2 means we're going to put a 0 in as that placeholder. So 0.075 times that X. Okay, so 0.075 times that X. Let's put this together though, right? These are like terms. They both have the same variable ending. So X is here, X is here. Remember, we've got this little imaginary 1 in front of that first X. So 1x plus an additional 0.075 x's is a total of, well, 1.075 x's. Now this gets to the tie-in, right, with our geometric sequences. I took this addition, we've turned it into a multiplication. So if I want x to be increased by 7.5%, I can just multiply the x by this number. It actually turns out we could have done something similar up in these two. We'll see how that works here in just a moment. Okay, same thing. Would you please do a quick check here of your work, and then we'll check in a little bit. So decrease this time. So 11% is going to be 0.11 of that y, so times the y. Remember, there's a little imaginary 1 in front, so put this together. 1 minus 0.11 is going to be 0.89. Let's just give that a quick double check. 0.11, sure enough. So 0.89y. Now let's take a look at these last two and see if we can figure out what's going on. Basically, what I'm saying is, I want to, in this first case, keep 100% of my x and add on 7.5% of that x for a total of 107.5%. Take a look here off to the side again. Just do a little thinking on that. 100%, so keeping the full original x, and then adding on another 7.5% is going to be, well, 107.5%. If we turn this into a decimal, right, and move this back 2 spots, what do you get? You get 1.075. Look how that works. Down here, similar thing is happening. I'm saying, hey, I've got 100% of this y, but I'm going to be losing some of it, losing 11%. Well, I'm going to reopen this sketcher. Sorry, that closed on me. Well, 100 minus 11 is going to take us straight to 89. So forgive me, we lost our work there, but we'll make it work. So 100% minus that 11% is 89%. And if you turn that into a decimal, move the decimal back 2 spots, that's going to give you that 0.89y that we started with. Now, the same procedure works up here. I'm just going to remind you, we ended up with 55 pounds. Well, let's see if we can get this same 55 pounds using this multiplier idea. I want to keep the full 100% of what I started with, that full 50 pounds, and then add on another 10%. Well, that's a total of 110%, which if we turn it into a decimal is 1.10, or just 1.1. Let's see what happens if I take this 1.1, this multiplier, times that original 50 we started with. 1.1 times 50, and look at that. We end up with that same 55 pounds. Now, I'm going to be honest with you. Generally, as mathematicians, we like this multiplier way better because it's a single step, just one multiplication as opposed to a multiply and then an add. So we've developed this shortcut going forward. So when we want to turn percents into multipliers, use this formula. You start with 1, your full 100%, and then add on the percentage you're changing. Write that percent as a decimal, and you should be good to go. Now note, when you're doing a decrease, just change that plus to a minus. So I'm going to now uncover several of these, and I want you to find what the multiplier should be. We'll do the first one together, and then the others you'll see more how it works. So in general, a 5% increase. Well, using our pattern up here, start with a 1 always. Increase means add, and turn 5% into a decimal. So move that decimal back 2 spots. That's going to be 0.05. Add those up, and there's what you got, 1.05. So to increase a number by 5%, you multiply that number by 1.05. Okay, let's have you give this next one a try. Okay, I hope you have tried yours and that you're just ready to check. I'm going to start with my full 100%. Let's actually write it in percents this time, see how that works. Decrease by 5%, which leaves 95%. Move your decimal back 2 spots to get your multiplier, and we should end up with 0.95. Now you, of course, can go straight to the decimal version. So you could have taken 1 minus 0.05. You're going to end up in the same spot, kind of like what we did over here, just change the plus to a minus. Next up, a 50% increase. You do yours. Pause, unpause when you're ready to check it. I'm going to use this same model. So start with 100%. Now 50% as a decimal is going to be 0.5. So yeah, move that decimal 2 spots. You got the 5 right after the decimal point. Add those up, 1.5. So to find a 50% increase of something, that's going to lead you to multiply that something by 1.5. 8% increase. Okay, you do yours, I'll do mine. Increase, 8%. Move the decimal 2 spots. Means I'm adding a 0.08 onto that. So to increase a number by 8%, multiply that number by 1.08. Okay, 2 more here to finish up. 35% decrease. Okay, here we go. Start with 100%, decrease by 35%. And with the subtractions, not a bad idea to double check your calculation. So 1 minus 35% leaves us with 0.65. Now, I want to talk about why that makes sense. So let's think about it this way. If you're taking away 35% of something, well, how much are you leaving behind? Well, 100% minus 35% means 65% is left behind. That's why you end up multiplying by 0.65. This is telling us how much we're keeping. And in this last one, a 1.7% decrease. Be very mindful of your decimals here. It gets tricky with percentages. Always move it back 2 spots. And so if you had to add it at 0, make sure you add in that placeholder of a 0. So 100% minus 0.017. So 100% minus 0.017 leaves me with the other 0.983. So 98.3% staying behind. 0.983. So to decrease a number by 1.7%, what you'll do is multiply that number by 0.983 because 98.3% remains behind.